In this tutorial, we will take a look at Residual Data Editor and use it to generate some whoosh sound effects. If you look inside Impact Data folder of the plugin, you will find Residual Object and Residual Data folder. As mentioned in the document, residual objects store encoded data. You can preview them directly like this. A residual data file references a residual object and decides how it will be decoded in residual synthesizers. For example, if you open a residual data file, you can see that it references a residual object right here. Let's start creating a new residual data file. I'll name it Whoosh. Firstly, we need to reference a residual object. You can choose any impact data to create whoosh sound effects. I will just use my favorite one, which is wood tabletop. Information about this object is also shown here. You can preview your output by pressing on Play Synthesize Sound button in the preview section. The energy over time and frequency distribution of the synthesized sound are displayed on the right panels. Note that the x-axis of this graph is not linear. It is scaled based on ERB bands to reflect how humans respond to different frequency ranges. I will increase the volume to make it louder. Most of the parameters in this preview section are kind of self-explanatory. Its seed is set to -1. A random seed is used each time we synthesize a new sound. You can see that our energy over time changes each time. If I set this to a positive number, now it's fixed. If I use a negative value for start time, the output signal is synthesized in reverse for negative frames, and back to normal on positive frames. This creates a pass-by whoosh effect. But more on that later. Note that, by default, in MetaSound's graph, residual synthesizers don't use these preview values. For example, let's create a new graph. And add a residual synthesizer node. Try lowering the speed, and play it. You get a completely different result inside MetaSound graphs compared to when previewing this residual data. You can set this pin to true if you want to inherit those preview values. However, it's usually better to control them directly so you can have more variations. When building a new sound effect for quick prototyping, you can set this to true. Now, let's get back to our residual data editor. Residual section is the most important section. Everything here will determine how a residual synthesizer will generate a new sound effect. Some of these effects can be hard to understand, but you will get used to them eventually. At the moment, we only have two phase effects: constant and saber. Effect scale decides how fast phases are changing over time. Constant is actually just saber effect with effect scale set at 0. They are pretty good for sci-fi sound effects. We have many effects for magnitude. Shift energy by ERB will circularly shift the entire frequency distribution of our signal. Its step size is based on ERB ranges. For example, you can see our frequencies are circularly shifted to the left on positive values. If you use negative values, they are circularly shifted to the right. Since the number of ERB is 32, the range of this value will be from 0 to 31. Shift energy by frequency is nearly the same as by ERB, but its shift direction is reversed. It also uses a linear range, so its step size is smaller than ERB. Since the number of FFT points is 1024, The range of this value is from 0 to 512. Normally, I will use shift energy by ERB to quickly test different frequency distributions, and find the one that fits my target. Then use shift energy by frequency to further fine-tune it or simply to create more variations. Next is rolling rate and chirp rate. Rolling rate is like a dynamic version of shift energy by frequency. It circularly shifts the entire frequency distribution at every frame. To visualize, it's something like this. But through every frame. Its value can be negative or positive, and there is no limit on its value range. Chirp rate is also similar to rolling rate, but it does linear shifts instead of circular shifts. So all frequencies can't go over the Nyquist rate. These two effects are good for both whoosh and sci-fi sound effects. You can combine them to make some interesting effects. Finally, Shift ERB min and max can be used to expand or compress the frequency distribution. If I increase the minimum value and decrease the maximum value, you can see that the frequency distribution is compressed. And if I reverse them, the distribution is expanded. Note that frequencies outside of the hearing range will be removed from the output. Amplitude over time modification curve allows you to modify the output over time. If you set this at custom, a rich curve editor will be added, and you can use it to shape the output like this. Shared mode allows you to use an external curve. Use this if you want to share the same curve between multiple residual data files. Amplitude over frequency modification curve allows you to modify the frequency distribution directly. It's similar to an equalizer, but the y-axis uses a linear scale instead of a decibel scale. We use a linear scale here because it's more convenient to completely cut off certain frequency ranges. Because all panels use the same zoom level for the x-axis, sometimes looks like this. So if you want to focus on a certain range, you need to have keys for that range. Select them and press F. This can be a little bit of an inconvenience. We plan to improve this in the future. That is everything you need to know about Residual Data Editor. Now, let's start making some whoosh effects. Again, by simply setting start time to a negative value, we already have a whoosh sound. I want the duration of my sound to be 0.4 seconds. So I will set speed to a smaller value. And now we'll use amplitude over time curve to cut its duration. I will also need to change the start time to match this negative duration. If I change the play speed here, you can see that we will have some very different variations. This is great because I can control it in my graph later. Also, you don't have to make it symmetric like this. Feel free to shift it to the left or right. You can have a finer step size by changing the time snapping. I want it to feel heavier, so I will modify its frequency distribution. Obviously, I can modify it by using a curve like this. Or I can compress its frequency range. Or just shift the pitch down. You can experiment with all of these and find the one you like. Sound fine, but Whoosh is all about moving. We need to add the Doppler effect. In case you don't know, the Doppler effect means the frequencies are changed based on the emitting source and the listen's movement. Wiki has a very good explanation for this. Here we can use chirp rate to simulate the Doppler effect. It's not 100% mathematically correct, but it sounds kind of similar. Just some small values will be enough to feel that movement. But let's try some weird values. With a high chirp rate, it becomes an UI effect. Let's set this to a reasonable value since we are creating a whoosh effect. If you want to make it sound like an object is coming toward, then moving away from the player, you can divide this effect into two parts. For example, one part is from -0.2 to 0. This part will have a positive chirp rate to make it feel like an object is coming. The other part is from 0 to 0.2. It will have a negative chirp rate and a high pitch shift to make it feel like an object is moving away. But I think this is enough for this effect. In Metasound graphs, I can use chirp synth nodes to add that extra layer if needed. We will explore that in Bullet Whiz by Sound Effects tutorial in the future. From this template, you can make a whole different effect by using different residual objects. These whoosh objects were actually created like this. I just rendered them and converted them back to residual objects so they are easier to reuse. Let's use this in a graph. Change this pin back to false. And it doesn't sound like a whoosh anymore. Copy my start time. Play speed. And pitch shift. Then play it. They sound the same now, but you can see that the graph isn't stopped after 0.4 second. It continues to synthesize some silent frames. This is a waste of CPU resources. So I will change this duration to 0.4. If you want to create a new residual object from this, firstly add a wavewriter node. Mono is good enough because our analyzer only uses one channel. play it. Then import the written WAV file. It's in your current project folder, saved, audio captures. Finally, convert it to a residual object and create a residual data file. And done. I hope you find this tutorial helpful, and I'll see you again on the next one.